Hey Year 12, so here we are doing 24B, which is using the graphics calculator to work out the probability of a normal distribution function or probability density function. So back in 24A, right, we looked at this normal distribution here and the curve. We looked at the function itself as well, and we also learned this notation here. And if you remember, the mu symbol stands for your mean, and the sigma stands for the standard deviation, okay? And that is going to be helpful for us in this next section. So here we've got our normal distribution, and you can see in this example here, the mean happens to be 10. Okay, and then you can see that bell curve shape. And so here you've got a normal distribution which is distributed about a mean of 10 with a standard deviation of 2.3. Okay, because remember 2.3 squared, that's the variance, right? And so x is here, I think, continuous normal distribution. And a question here asks us to find what is the probability of x, like some event x, so that the results are greater than or equal to 8 but less than or equal to 11. So let's just say it's, I don't know, maybe points in a game or something, and the mean or the average is people get 10 points for playing this game. And so it's asking for what's the probability, of someone playing this game and getting between 8 and 11 points. Okay, so it actually, we can work out this probability by working out the area under the curve. So in theory, it is, well, with our integration notation, which we are very familiar with now, we could say it is the integral between 8 and 11 of the probability density function f of x, integrated with respect to x. Okay, though we don't have an equation for this one, or also it is also a bit tricky and hard. We saw that in the last one. We can actually just plug it in the calculator. It is super easy for us with the graphics calculator. I have put a video over here on YouTube for you to watch, so please watch it. That'll be more helpful, and it's using the TI Inspire. Very clear instructions on what to do. That'll be easier, I think, for you to watch it there rather than me trying to switch to the camera and trying to do it under the camera on the iPad for you. So in this example here, if we want to work out the probability of x being occurring between 8 and 11, where the normal distribution has a mean of 10 and a standard deviation of 2.3, you basically just type it into the calculator. You use the statistics function, and you go to distributions and you type in these values. You literally type in, the value 10, 2.3, and the upper and lower bounds is 8 and 11. You just type those in and it gives you the answer, okay? But what does this mean? This, in fact, is the one that's in this diagram up here, okay? Between 8 and 11. So I might just do a rough little sketch just so then you can kind of visualize what this is talking about. So let's do a little sketch. So there's my mean is 10. Standard deviation is 2.3. So that means the next sigma going along here, that'll be like 12.3. Yeah, and if I take away 2.3 this way, what will that be? 7.7. Yeah, okay. Now we want between 8 and 11. So let's say 11's here somewhere, and 8 is like here somewhere, right? So it's asking us for the probability between there, which is in effect the area under the curve there. Does that make sense? So there's 8, 11, okay. Let me just put down here for you, that's mu, and this is mu plus sigma, right? And this is mu minus sigma, okay? And you just type in the calculator, and the answer we get is actually Let me actually just move this down so we've got a bit of space. It is, we should write the notation properly. So we should say probability of x occurring between 8 and 11 is approximately, if we round off to 3 significant figures, you should get 0.476. Remember, approximately, because we are rounding it off. Okay, it is not exact. Part B, same thing. You've just got to watch the YouTube video and then follow along with your graphics calculator to figure it out. But let's just visualize what this means. If I want the probability of being able to get a score that is, say, or an x that is less than or equal to 12. Okay, there's 10. 12.3 is there. 12 is like here somewhere. Less than or equal to 12. So that means all this bit down here. Now you can see, because it's a continuous distribution, it's not discrete, less than 12 is the same as less than or equal to 12, right, as well, okay? It's going to be that same, it's the same shaded area, okay? So do this on the calculator, guys, and you should get, let me check, it should be 0.808, okay? Look good, and then part C, same idea, except this time, let's have a look. There's my mean is 10. I want x greater than 9. So let me put in my standard deviation, one standard deviation to the left and to the right. Okay, 7.7 to 12.3. I want greater than 9, so maybe 9's about there. And so I want all of this. All of this tells me the probability, the sum of all this area here that I'm colouring in yellow, gives me the area, the area gives me the probability of getting an x that is greater than 9. So if we use the game and point scenario again, it's the probability of, you scoring greater than 9 in this game, okay? And the answer should be, let me check for you, it should be 0.668. Please let me know if you can't get it working on your graphics calculator, okay? Let's do example 2. It says, in 1972, the heights of rugby players were approximately normally distributed with a mean of 179 centimetres and standard deviation of 7 centimetres. Find the probability that a randomly selected player in 1972 was at least 175 centimetres tall and then between 170 and 190. Okay, so what have we got here? We've got x here. Let's just set up the situation. So we've got an x value that is normally distributed with a mean of 179 and a standard deviation of 7. Okay. Now let's do a little sketch. I would encourage you to do this every time because it just helps you visualize and understand what the numbers actually represent. So here, my mean is 179, standard deviation is 7. So if I go 179 plus 7, go to 7 along this way, that would be 186, right? And if I minus 7 this way, that'll be 172. Is that right? Yeah. And so that's your mu plus sigma, right? Mu minus sigma. And you can continue and add more standard deviations on the left and right. I'm just going to draw those two. And so if I want the probability that a randomly selected player is at least 175 centimeters tall. So 175 centimeters is somewhere here, right? So he's got to be at least that tall. That means he's that height and taller. So that means all of this. Okay, so you just got to put that in the calculator for me. Okay, follow the video, and hopefully you should get, let's see, probability, just put part A, probability of x being greater than or equal to 175 is approximately, hopefully you get about 0.716 on the calculator, okay? Which is, you know, if I asked you for that as a percentage, what is it? Well, it's 71.6% approximately, which is quite high, isn't it? And then between 170 and 190, same deal, put in your calculator, but let's do a rough sketch so we understand what it means. So we've got 179 in the middle here. Here is like 172. If I take away another 7, what do I get? 165. Over here, if I add 7, I get 186. Then I add another 7. What would that be? 193. So I want between 170, which is like here somewhere. Actually, I might change colour so I can stay consistent and it's a finer pen. So let's say that's 170. Okay, going to 190, which might be about here somewhere. Okay, so all this area here under my normal curve, that will give me the probability of getting a value of x that is between 170 and 190, or someone that is a height of 170, between 170 centimeters and 190 centimeters. So do that in your calculator, and we should get, now just be careful with your notation, it seems silly, but between 170 and 190 does not include it. It doesn't say at least 170 as well, or at most 190. So here we just have to use the inequality that does not include the equals, right? Okay, so between 170 and 190, use your calculator, you should get approximately 0.843 to 3 significant figures. Okay, and then last example, let me move this down for you. Okay, what have we got? It says, the time taken by students to complete a puzzle is normally distributed with a mean of 28.3 minutes and standard deviation 3.6 minutes. Calculate the probability that a randomly selected student took at least 30 minutes to complete the puzzle, and then out of 10 randomly selected students, at most half of them took at least 30 minutes to complete the puzzle. So what have we got? We've got x, which is normally distributed across with a mean of 28.3 and a standard deviation of 3.6. Okay, so you've really just got to use the calculator here. It's fairly straightforward. You can just plug it in, and to get a student, the probability of a student taking at least 30 minutes, that means x has to be greater than or equal to 30. Okay, put that in the calculator, and hopefully you get approximately 0.318. Okay, and then in part B, yep, I'm just checking. Okay, part B says, what's the probability that if you, out of 10 randomly selected students, at most half of them took at least 30 minutes to complete the puzzle. So instead of just picking one person, it's saying like, what's the probability out of 10 of them? So it's like you're kind of doing 2 layers here, 2 steps. So we kind of need maybe another pronumeral to help us label what we're doing. So let's say let capital Y be the number of students who took at least 30 minutes to complete the puzzle. Okay, so now we have like a new normal distribution though. So like y is normally distributed, actually no, it's not a normal distribution now, hang on, it's going to be, I think, a binomial distribution, because you either took at least 30 minutes or you didn't take at least 30 minutes to complete the puzzle. So it's going to be B instead of N this time. So this is what we did in the last chapter. So go back and review that if you can't remember how to do the binomial probability distribution. So then the mean is, oh no, sorry, it's not mean, it's N and then P, remember? So N and P. So the number of trials you do is 10. You pick 10 kids. What's the probability that someone took at least 30 minutes? We worked it on part A. It is 0.318. Now I would suggest don't use 0.318 because we rounded it off up here. I would leave the whole number in the calculator or bring it back up or put it in the memory and then use it down here. So now you've just got to put all of this in the calculator, but you've got to use the binomial probability distribution function, not the normal one. You've got to use the binomial one, put it in, and hopefully we should get for this event, for this for this y to be less than or equal to 5, because it says at most half of them. So at most half of them. So that's 5 students, right? At most. So that means it has to be less than or equal to 5. Does that make sense? Yeah, because at most 5, not more than 5 kids. And if you do that on the calculator, you should get about 0.938. Okay, so please have a go at the questions. That is exercise. Let me write it down for you, Year 12. It is exercise 24B. And it is on page 637 in your textbook. Please have a go and let me know if you need help.